All right, so I'm going to give you a basic format for this, and we'll do a couple examples after that. If we are graphing y equals log any base, I'm just going to put b here, of x. This becomes a little challenging, right? So what we're going to do here is we're going to rewrite this. I'm not doing the inverse. I'm just rewriting b to the y equals x. Now, when this format, these are the same. Again, these are the same. These are not inverses because I didn't switch x and y. In this format, it's way easier to plug in negative and positive values, any values as y than x. Here, and the same would go over here. We'd be doing the same calculating. So what we're going to do here is we're going to go ahead, we'll make a little table. It can be, as many or as few values as you need. Probably this would be good. Well, and we're going to do things. So this would be b to the 0, which is going to be 1. And then each time it's going to be the powers of b. And now this is going to seem pretty abstract. Oops, so b to the negative 1 would be 1 over b. And 1 over b squared. Okay. Really all we need to know is that these are small values. These are close to 0. No matter what b is, as b gets bigger, it's going to get close to 0. Granted that as long as b is bigger than 1, right? So let's plot some of these points. What that's going to look like is we're always going to have this point, and you're going to have to ignore the fact that I put scaling on this. We're always going to have this point 0, 1. So we'll ignore our y scaling for time being. I'll remember to put no scaling on yours. And we'll always have this point right here that will be consider b, comma, 1. So we'll always have this kind of graph like that. And we'll always have 0 or 1, 0. And then as the x increases, we're going to keep getting a little higher, but it's going to kind of taper off a bit. It's kind of like this. And on this end, as x becomes negative, we get numbers that are close to 0. So we end up getting a vertical asymptote there. Okay, so this should seem a little abstract right now, but we'll go ahead and put this in. So the domain for these graphs, the domain without any shifts is going to be x is greater than 0. We're not getting lower than 0 in the x. The range is going to be all real numbers. And the asymptote is going to be at x equals 0. It's a vertical asymptote at 0. We'll start shifting those around and whatnot, but for right now we'll keep it at that. So again, our general graph, I'm going to draw this a little better this time for you. I'm going to keep the scaling off it to kind of keep it a little cleaner. What we're going to do is we're going to have, always going to have the power 1, 0, and then whatever b is, and then b squared, this will kind of be our general format for this. So we'll have b, 1, and b squared, 2. 1, 2. Scaling is not great on this, but it's doing okay with an asymptote. All right. What you want to think of this is like the exponents that are coming out, and these are like the outputs. So let's do some actual examples. All right, so I mentioned it before. It's easier to think about this as 5 to the y equals x is going to be a way easier way to do this. That way I can plug in exponents as y, and I'm just going to use these simple values. At 0, we'd have 1, we'd have 5, and here we'd have 5 squared, which is 25, and here we'd have 1/5. Right? So let's go ahead and plot those points. Nothing too crazy. Oops, sorry. So I got 0, 1, 5, 1, and all the way up here, 25. And then I know that this side of the graph is getting close. The x values will get smaller and smaller and smaller, but not cross 0. So I'm going to kind of come up, see as best I can to kind of go whoop. And there will be my graph. The domain will still be x is greater than 0. The range will be all real numbers, and the asymptote will be at x equals 0. That will stay the same until we start transforming. Sorry if my video is getting a little shaky. I'm moving this around a bit. So similar thing here. I'm going to do 1/3 to the y equals x. And I have y values here. So let's do this. 1, 1/3, 1/9, and this would be 3. So this gets a little different. It's just going to go up in this direction now. So let's go ahead and we're going to plot this. We might actually would have wanted maybe, what do we get when y equals -2? So let's kind of flip that into my table as well, just since that'd be a nice clean value. Okay. So let's plot these points. We have we still have 1, 0. And now we have x at 3, we have -1. So we're going to go down here. And so our graph is just kind of upside down from what it was before. At 1, we have 1/3. So let's see, or at 1/3, we have 1. So that's going to be about here. And so you notice that my asymptote's still the same. It's just that I approach it from the other direction. And so one of the points that I'm aiming for here is 9, -2, which would have been way off screen over here. And I just realized I did not film any of that. Damn it. So here are these points plotted. I was drawing them without the camera pointed at them, but we have the point 1, 0 from our table. And we have to notice that as x gets smaller, our y in fact gets bigger because it was a fraction, so it's an inverse. You might notice if I take these graphs and I rotate them, they look more like our exponential graphs, right? So like that's something to kind of think about as we do these. They are inverses. So if we looked at an inverse like this one, it says, now this says find the inverse. So we want to find the xy switched, right? So like if I did x equals log base, this is the inverse because I switched x and y. This would be 5 to the x equals y, which would be 1, 5, 25, and 1/5. And this is the exact opposite, the xy switched of our other table up here.